I'm going to make this foot fungus cure explode. Potassium permanganate is a chemical that comes in many forms. It's most commonly sold in this powder form, like my pharmacy very conveniently provided to me to cure foot fungus. It also comes in this crystalline form, often called Conti's crystals, and it dissolves in water to produce this beautiful magenta colour. But it does stain your hands brown, hence the gloves. All that aside, it has some very reactive chemical properties. Let me explain. The potassium permanganate molecule is represented as KMnO4. You've got the potassium, a fairly useless placeholder ion, then the manganese bonded to 4 oxygen atoms. Having this much spare oxygen lying around makes it a brilliant oxidizer. This is to the point where it's very commonly used in high school chemistry, along with potassium dichromate, to oxidize hydrocarbons. Thankfully, what these high school students don't know, however, is what these oxidization properties allow us to do. Let me introduce you to flash powder. Flash powder is a very useful tool for filmmaking and science. It's a pretty common pyrotechnic device that combines the use of a metallic fuel and, very conveniently, a strong oxidizer. Once combined, the substance will burn very quickly. For my fuel, I use this very fine aluminium powder that I got from a very dodgy arts and crafts store. Now here a problem arises. My potassium permanganate isn't very fine at all, which makes the reaction very difficult to start off easily. So I solved this with 2 different chemicals. First, I added sulfur, which basically acts as an accelerant, letting the reaction start at lower temperatures. Then I used these magnesium filings, which burn at over 1,000 degrees, making the reaction start very easily. Now all I've got to do is find out how much of each ingredient I need to create the best reaction. So now it's time to do some tests. So I've started without sulfur to see how the reaction works. I started with a 60-40 split of potassium permanganate to aluminium, ranging down to a 90-10. But now it's time to scale up the sulfur, see if that improves things. So from this, I've decided to use about a 3 to 2 to 1 split by mass of permanganate, aluminium, and sulfur. But Tim, they're not explosions. Hold on, it's coming. Flash powder, like a lot of other chemical reactions, will react a lot more aggressively. It's compacted and confined. So I used my amazing artistic ability to design and print some small capsules to hold the powder. Here our next big problem arises. I do not want to be lighting each reaction with a blowtorch or a match, especially if we're looking to explode something. But there is a solution. We know that potassium permanganate is a great oxidizer, so why don't we stick something else that can oxidize in? Enter glycerin, a thick, sweet-tasting liquid that can, in the right circumstances, make you shit yourself. All of its lovely hydroxyl groups make it the perfect candidate to being oxidized. So, all we do is add it to some pure potassium permanganate, leave it a while, and we have our chemical fuse. And now it's finally time to use our capsules and see how that changed the reaction. Now it's time for the final test. We've got about 4 times the amount. God, I hope this works. So, what did we learn? Nothing. We learned nothing.